Well, hello Internet, and welcome to my C++ programming tutorial. In this tutorial, I'm going to teach the entire C++ programming language in one video. In the description underneath the video, you're going to see links to all the individual parts, so that should help you get it to exactly what you want. And I'm not going to waste any time covering installation. If you guys want me to cover that, just leave a comment down below, and I'll do that later. So I have a lot to do, so let's get into it. Okay, so what I have here on the left side of the screen is a basic text editor. What I have here on the right side of the screen is a terminal. Everything's going to be exactly the same as long as you use G++ to compile your programs, no matter if you're on Mac, Windows, or on a Linux operating system. So the very first thing we're going to do here is cover comments. This is a comment. Just like many other languages, you can create a comment just by putting two dashes and then whatever you want. And if you want a multi-line comment, you can just type in multi-line and then close that off. So there is commenting in C++. First thing we're going to do here is include some outside libraries. We're going to have some functions that we're going to want to use. So this one's going to allow us to use a function called cout and a whole bunch of other different things you're going to see here in a second. That'll be used for vectors. This will be used for strings, and then this will be used for file I/O. Now all of your code is going to be contained inside of a main function like this, and then you're going to have a curly bracket, and then you're going to have a closing curly bracket. Now inside of here, you could call the function cout either using cout or std cout, like this. What I want to do is get rid of this part, and how I get rid of that is right here, right after the include statements. I'm going to type in using namespace st, and that's going to keep me from having to type that out every single time. Now if you wanted to do a basic hello world type of statement here, all we're going to have to do is type in hello world using cout, which outputs the text that we have here, and a carriage return whenever we type in the same brackets you see right there, and end L. That's for the carriage return, and this right here is saying we want to output this on our screen. The other thing we'd need to do here is call return 0. You're always going to do this, and 0 stands for the execution went through perfectly fine. So just to keep everything simple. Jump over here in the terminal, and this is the command I'm going to use to run this. It's called ctut, and make sure with your C++ programs you always end them with cpp as the extension. And then right here I'm saying that I want to use the version 11 of C++. Then I'm going to compile that, and then to run it I'm going to put /a.out. And if you're on Windows, you would just type in A, and you can see hello world prints out right like that. So the next thing we want to discuss here are variables and data types. Now variables start with a letter and can contain, of course, additional letters, numbers, or underscores, but they must start off with a letter. And here we're going to actually create a constant variable, which is going to be of type, data type, double, which means that it contains floating point numbers or decimal places. And here we're going to give it the value of 3.1415926.535. And once again, constant being here just means that this value cannot be changed, and normally whenever you define constant variables you make their names in all uppercases. Other data types that are available to you are characters, which contain just one character, and they are going to be surrounded by single quotes. So let's say I have a grade equal to and A, right like that, and there you go. And a character very specifically is going to take up 1 byte inside of memory. Booleans, which normally start with is whenever you're defining the variable name, can contain true, which is going to be comparable to 1, or false, which is going to be comparable to 0. Ints or integers are just whole numbers without decimal places. Floats are floating point numbers just like doubles, and they normally are accurate up to 6 decimal places. Let's just say favorite number and just copy this guy. And doubles, of course, like I said before, are also floating point numbers, but they tend to be accurate up to around 15 digits in length. And then of course if I want to output one of these variables on the screen, I'm going to use cout again, and then I could say favorite number inside of double quotes, and then to output it I just put another bracket inside of there, favnum, and then of course end L for a carriage return, and there you can see favorite number 3.14159. Now, of course, there are other data types that are available. We have short ints, which are going to be at least 16 bits in size, long ints, which are going to be at least 32 bits, long ints that are going to be at least 64, unsigned ints, which are going to be the same size as the signed version, and long doubles, which are not less in size than regular old doubles. If you want to find out the number of bytes for a data type, we could come in here and go cout and say something like size of int We could then call up size of and put my age inside of there since it is an int. And inside of C++, all statements end with a semicolon, so we could just jump down here, keep everything on the screen, and go like that. Compile and execute. You can see right here, size of an int is 4 bytes. If I would then go in, do exactly the same things for characters, booleans, floats, and doubles, and execute, and you can see how many bytes are in each one of those as well. If you're wondering how big a number can be based off of bytes and so forth and so on, let's go in here and let's create the largest int that we can possibly create. And whenever we know the fact how many bytes an int can contain, we can then go in and define exactly how large that number would be. And you can see right here, this is the biggest integer we could possibly have. And if we went down here and said, hey, let's go and output that like this, and you can see it prints out exactly the way that you would expect it to. However, if we go 1 over and put an 8 in there instead, save that, and recompile, you're going to see that you get completely different results. See, it comes back as a negative number. That's just a demonstration of what happens whenever you go outside of the bounds using your different data types. When it comes to arithmetic, you're going to be able to use plus and minus and multiplication and division, as well as modulus, which is going to return the remainder of a division. We're